Ladies and gentlemen, we greet you. Standing in front of you is Mr. Spambo, MC, along with Miss Mnisi, TP. So today we are going to make a presentation under the topic that says chemical equilibrium. So first I'm going to analyze what chemical equilibrium is, that is going to go with examples. So chemical equilibrium is a dynamic equilibrium where the reverse reaction is caused to a forward reaction. So the factors that affect chemical equilibrium, the first one is temperature, the second one is concentration, the third one is pressure. So the fourth one does not affect chemical equilibrium, although it speeds up the reaction. I will leave it to Ms. Mnisi.
Chemical equilibrium is very important because it helps us understand many industrial and natural processes. For example, a Haber process is used to manufacture ammonia for fertilizers depending on equilibrium principles. Equilibrium is also important in medicine, environmental science, and biological systems.
Many learners or students still develop misconceptions and struggle to understand how the chemical equilibrium or the reaction still continues even when the system reaches dynamic equilibrium. So after this dialogue, I'm going to show practical examples and other diagrams to show how increasing in temperature, concentration, and pressure will affect the equations.
In this presentation, we will have a dialogue discussing chemical equilibrium. We will demonstrate common misconceptions that learners usually have.
We will then explain each of these misconceptions to help learners understand better of what chemical equilibrium is. Thank you. So we are back again on the second video where we're going to be using diagrams and visual examples to explain further about chemical equilibrium. So first we will have the first point, which is the definition of chemical equilibrium. So it is said to be a dynamic equilibrium where the reverse reaction is equal to the forward reaction. So in other words, it means that these are reversible reactions.
We also have examples that affect chemical equilibrium. Which is temperature, concentration, and pressure.
So as we said in the first video, that we have temperature affecting the forward reaction and the reverse reaction, and we also have concentration, and we also have pressure. So we have the last one, which is we call a catalyst. So the catalyst does not affect the rate of chemical equilibrium, although it speeds up the rate of the reaction. In other words, it decreases the graph by decreasing the time. So we will have an example of the reaction one example of a reaction. So we can have A plus B reverse forward, which is going to be a C. So it is said that A plus B can be a reverse, can be a forward reaction of C. Meanwhile, A plus B can also be a reverse reaction of C, which is C going to be A plus B. So explaining the first misconception in this, although the reaction can be, the dynamic equilibrium can be reached. Alright, so continuing from this, it means that if we can take these ones are going to be our reactant, and this one is going to be our product. So it means that this can change into this, just as we demonstrated here, and this can also change into this. The products can change into reactants, and the reactants can also change into product, only when the equilibrium is reached. So it is said that the reaction does not stop. It continues even if equilibrium is reached. So what happens is they happen very fast, and they also happen at the same rate, which means time. So the concentration, speaking of concentration of, let us see that we have a reaction between A and B. So our A here is our reactant, while our B is our product. So, it is said that the concentration of these two is still going to be constant or the same. So now we are going to have an example of the graphs when the pressure increases, decreases, and when there is no change in pressure. So we're going to have the first one, the reaction of N2 plus H2, nitrogen gas plus hydrogen gas to produce ammonia. So what we're going to do first is to balance the chemical equation. So here, because we have two nitrogens and this side we have one, so here we can put the two. So now because we have two nitrogens and two nitrogens here we have two hydrogens and we have 6 of them here. So here we can put a 3, this will multiply with that to make 6, and then we're going to also have a 6 there. So let us say that we have 4 moles here in the reactant and in the product we have 2 moles. So it is said that this is going to favor the forward reaction, which means that the graph is going to shift to the right. So we're going to have our pressure there, and then our time here. So you can have T1. So here we will have our reactant at 4 mole, and then here we're going to have our product at 2 mole. So what is going to happen here is that the graph is going to shift to the right. So this is what is going to happen. We'll have a graph like this, and also the products are just going down. Meanwhile, this one is going to increase. And then after that, the other one under the same equation that you can have, it is for when the pressure decreases. So we also have T1 here. This is our reactant, and this is our product. So this one is going to decrease, while this one is going to increase. So the last graph that we're going to have is for when there is no change in pressure. So these are going to be our reactants, and these are going to be our products. So it is said that there won't be any change. So the graph does not shift and does not decrease or decrease. Right, so we are back to explain on a dialogue further about chemical equilibrium. So in this dialogue, we're going to be asking and answering questions. Over to you.
I still do not understand chemical equilibrium. If a reaction reaches equilibrium, does that mean it will stop completely?
The reaction does not stop, although what happens is it happens fast, and both the reaction, which is the forward reaction, and the chemical reaction, they happen together at the same time, and they happen very, very, very fast. So it doesn't mean that it stops, it still continues. That's why we still have the forward reaction and the reverse reaction. So, explaining further, do you remember the examples of the factors that affect chemical equilibrium?
Oh yeah, I remember them. The factors that affect chemical equilibrium are pressure, temperature, and concentration. What about catalyst?
Well, catalyst is also a factor that affects chemical equilibrium. But the thing with catalyst is it does not really affect the reactions. You understand? Unlike temperature, concentration, and pressure, the catalyst, it only speeds up the reaction. So its work is to speed up the reaction only. You understand?
Okay, I understand. Another thing I don't understand is pressure. I think increasing pressure increases the amount of product.
No, I do not think so. What I think is the reaction always favors the reaction that has less number of moles.
Okay, let's talk about what happens if pressure increases. I mean, the product increases because pressure pushes the reaction forward.
No, if you remember the examples that I used previously, where I had nitrogen gas reacting with hydrogen gas to produce ammonia. So when you saw there on the reactant, which is N2 plus H2, we had 4 gas moles, right? So on the products, ammonia, we had 2 gas moles. The forward reaction was only favored because the forward reaction is only favored because the product was the one with lesser gas moles. So as you saw there, we have the forward reaction and the reverse reaction. So what happens is, if the reverse reaction has less gas moles, let's just simply take it like this. If we had N2 plus H2 with 2 gas moles, forward and reverse, and then we had ammonia with 4 gas moles, the reverse reaction was going to be favored instead of the forward. So what depends is which one has more gas moles. You understand?
Okay, now I understand.
All right.
Thank you.